In this video, I'll be showing you how I made this amplifier with a built-in VU meter for my bookshelf speakers. Here you see the body of the amplifier being built. I did a 45-degree bevel on all sides, and then if you look at the back, there's a channel, this is called a rabbet, and the back plate of the amplifier where the speaker hookups and the inputs go fits in there. The display of the VU meter are these LED rings. They hook into the line-in voltage of the amplifier and monitor it for changes in voltage. Here you see everything hooked up, and I'm running a test pattern just to make sure the signal wire and the power wires are connected properly. The wiring looks a bit more complicated than it is, so I'm breaking it down into steps. If you look in the top left corner, you'll see the Chromecast audio, which provides the signal to the amp. It runs to the amp and then out to the speakers. This is a traditional speaker setup. The next part of the setup is hooking up the Arduino to the line in of the amp coming out of the Chromecast audio. It hooks into the left and right channel and goes to the Arduino so the Arduino can monitor the input voltage. Here's where it starts to get a bit complicated. The input voltage of the amp is 12 volts, but the Arduino and the LED rings need 5 volts. So what I'm using is called a buck converter. You can see it in the middle there where it drops the voltage from 12 volts down to 5 volts. You need to branch the power from the 12 volt source to the amp and then pass the 12 volt into the buck converter, convert the voltage down to 5 volts, and have that voltage go to the Arduino. The last step is hooking up the LED rings to the Arduino. The Arduino passes a signal out to the first LED ring on the right, and then the signal continues from that LED ring to the LED ring on the left. Once you have that soldered in place, then you have to solder the positive and negatives of the voltage to both LED rings, and everything should work. Depending on your input source, the input voltage might be a little too hot for the Arduino to monitor. If that's the case, there's a very simple circuit that you can create that will drop the input voltage down so the Arduino can properly monitor it. You want to make sure that you have a clean signal coming into your Arduino so you don't have any ground loops happening. Here you can see me testing with serial input. The front and the back plates of the amp were designed in Fusion 360. Here you can see the front plate with the 2 holes for the LED ring will be glued in place, and a hole for the potentiometer, which acts as a volume. This is then printed out on my 3D printer and assembled into the case. To make things look nice, I use a wood veneer and glue it to the front plate. If you really crank up the brightness of the LEDs, they will shine through when they are on and be invisible when they are off. Here you can see the buck converter in place. You have the input voltage coming in from the source, and then it goes to the buck converter and gets dropped down to 5 volts, and then goes to the LED rings, which are secured in place on the plate that I printed out. Code for this application was provided by Eric B. Creator, and I've got the link right here. It'll be in the source code. I've modified it a bit because you can see that it was designed for a bunch of different matrices for LED rings and strip, and so I defined my own. But aside from that, this is really well commented code. It's easy to follow, so you can go through and add buttons if you so choose, or use a different LED shape. You can follow through and change all the values and change the color settings, and it's quite easy to follow, so go check it out. There you have it. I normally post links to the 3D files, but this was custom for this case, so they won't really be of benefit. Links to the code will be below.